today we are doing Fig 4, and Fig 4 is transformation. And it is exponential and logarithmic. So here is a review of all the different transformations that we have done since chapter 1. So this is not the first time, nor is it the last time you will see this stuff. You're still doing it. We've got the f of x notation, which we'll review at the end of class today. We've got examples with actual numbers plus what the transformation is happening. The first thing that you want to do when you see the homework questions, when you see a question on a quiz, is determine if we have exponential or logarithmic. So look, do we have exponential or logarithmic? Exponential. How do I know it's not logarithmic? Because it doesn't say log. So exponential, we don't have to do as much work for. First thing, we have f of x equals 1/2 to the x, and then g of x is 1/2 to the x minus 4. So we're going to, since this is exponential, we'll go ahead and make a table. And with exponentials, we choose key points like 0 for x and 1 for x. We plug in 0 for x, 1/2 to the 0 is 1. 1/2 to the first is 1/2. Knowing that the b value is 1/2, what kind of graph is this one going to be? That's decay, because b is between 0 and 1. We know this is going to be decay. And usually, if we have a decay, these are not the friendliest points to graph. What's another good x I can throw in there? If I put in -1, that will reciprocate 1/2 and give me 2. There's one more thing I'm going to put into my table, and that is the asymptote. What is the asymptote for exponentials? Y equals 0. Yes, equals. So I will graph that. At y equals 0, that's an asymptote. That's just a dashed line that you can't even see because I'm doing it on top of a black line. Graph 0, 1, graph 1, and then half. Graph -1, 2. What does the asymptote mean for the graph? What's the asymptote mean for the graph? What's the graph doing? What did you say? It's not going to cross through it. It's never going to touch it. But what is it doing? To the asymptote, what is it doing? Louder, Jacob. It's getting closer and closer and closer and closer and closer. So we'll cross through it. Because of that, knowing what the asymptote is, this helps me draw the graph without finding a ton of points. Now, our transformation. What does the -4 do? Translate, thank you for saying the correct word. Translate down, how many? 4 units. Now, you could just use the graph and take every point and move it down 4 units. I'm going to use the table, just make sure everybody knows what to do. But if I'm translating it down 4 units, does that go to my x's or my y's? And I'm going to subtract 4 for all the y's, including the asymptote. So because the asymptote is y equals 0, I can subtract 4 and change my asymptote to y equals -4. So including the asymptote. And then when we graph that, we don't graph the old y's, we graph the old x's and the new y's. So my asymptote has now moved down 4. I just laugh every single time I say asymptote. It's not funny. It's just the first one who laughed. Do you laugh when you hear asphalt? That you drive on? assignment. Spell it. Geometry, when you did like side angle side, and when you did side angle.
I did laugh at that one.
Guess what? In pre-calc we do angle side also. It's a pain in the rear. Okay. So I have my transformation and my graph. Next. Good? Okay. Hey, why didn't I switch the X's and the Y's? Because it's not log. Yeah, we didn't have to do inverses because it's not log. That's you only do those for log. Alright, example 2. Scrap the transformation of f of x equals e to the x, represented by g of x equals e to the x plus 3 plus 2. Then graph each function. So, what is e to the first? What number is e? 2.718-ish. If you don't know that, write it down. Because I'm going to do this one without the calculator. It'll be fun. So I'm going to start with f of x. And I'm going to choose 0, plug that in for x, and I get 1. I'm going to choose 1, plug that in for x, I get 2.718. And my asymptote is at y equals 0. So I'm just approximating 2.718. And I know that my graph is getting closer and closer and closer to the asymptote. So I'm approximating my graph as good as I can. Then I'm going to use transformations. What transformations are taking place? What's the main word? Translate. Which one? Let's start with the x plus 3. The x plus 3 is not in parentheses, but it technically is in parentheses because you would have to do the exponent in its entirety. What is that word? You have to figure out what x plus 3 is first before you did e to the x plus 3. Like you would have to do that first. So there is technically parentheses there, even though they're not written. They can be written. So x plus 3 is with the x, so the horizontal. And remember, horizontals are opposite. So which way is this one going? Left. And 2 is translating up. I feel like we don't have to sit here and really describe every single transformation anymore. I hope. Even though I'm still doing it. Okay, so now my table, to the x's, I will do anything horizontal, which is subtract 3. And to my y's, add 2. So when I add 2 plus 2.718, I now have 4.718. And to y equals 0, I'm going to add 2, so now I have y equals 2. Oops, except for I didn't write it. Y equals 2. So I'll go over and put my asymptote at y equals 2. Graph negative 3, 3. Graph negative 2, 4.718. Connect those points and use the asymptote. Doesn't even need to pull the calculator out. All right. The next one, please don't work ahead on this one. The next one has a trick to it that I feel like we talked about it a very long time ago, but it's been a while. So I'm going to have to talk about this one. And this is going to be important. as you get to higher level, when we go to graph these, if you have multiple things happening to the x, you have multiple things happening to the x, before you can tell me the translation, you have to separate these two transformations. I have to rewrite this for g of x. What I have to do is I have to pull the 3 out. It's still going to be in the exponent, but I have to pull it out of the 3x minus 5, just like we would factor it using greatest common factor, but it doesn't factor out of 5. What operation, I'll write it where I have a little bit more space. If I'm trying to factor out 3, I'm using what operation? If I'm factoring out 3, what did I just do? Dividing it out. So here I'll have x minus left over, but what does this number become? What's this number? It's 5/3. So if you have a number in front of the x and there's other stuff happening, like a translation also, before you know what that translation is, you have to pull the 3 out. Otherwise, you're going to have the wrong translation. You will have the wrong graph. Okay, now I'll go ahead and do my table and stuff like that. So our f of x is 3 to the x. Is this logarithmic? No, so we won't have to switch anything. We'll just use these points, 0, 1, 1, 3, and y equals 0. Then I'm going to use transformations. What transformations are happening here? There's 2. Where's the 3 located? But it's with the x still. Like in the previous step, it's still part of that exponent. And these are exponential, so anything in the exponent is horizontal. If it were vertical, it would be in front of, it would be a big number. Okay, so that was a good thing that she said that, so I could explain that. Anything in the exponent is horizontal. Anything in the exponent. So this 3 is a what? It is a horizontal string. Factor of 1/3. And then what about the minus 5/3? It's horizontal, so we do opposite. We're adding 5/3. What does that do? What's the fancy word? Translate. Which way? Translate which way? Right. 5/3. And if that's too hard to think about on a graph, you can think about 5/3 being 1 and 2/3. That's a little bit easier to think about when we do graphs. 1 and 2/3. So in my table, both of these things are happening to the x. So in my table, I'm going to do both things to the x. Which of the two has to occur first? Multiplication or addition? Multiplication, we do order of operations. So I'm going to multiply by 1/3 first, then I'm going to add 5/3. So I'm going to take 0 times 1/3 and 1 times 1/3. Do I need to multiply by asymptote? No, because that is in the y column. Then I have to add 5/3, so I get 5/3 here, and then I get 5/3 plus 1/3 is 6/3. Or 2. So you've got the outermost x's and the outermost y's. So we'll have 5/3, which is 1 and 2/3. up 1, and then 2, up 3. And we have the same asymptote at y equals 0. I'm going to say the word asymptote for the next chapter too, just so you know it's going to happen for like way more chapters. Get it out of your system. Okay, this next one, I'm probably not going to do all of it because this one's a horrible graph. But, maybe I'll do it. I don't know. We'll see how far I want to go into it. But I do want to, for this next one, I do want to tell you about the transformations. So when they ask for the transformations, they want to know the transformations from f to g. F of x is e to the negative x, and then g of x is negative 1/8 e to the negative x. What is changing from f to g? From the first equation to the second equation, what's different? The negative 1/8. That is the only thing different. So this negative x up here doesn't change. So when I talk about what's different, when I graph the transformations, I'm only using this negative 1/8 as describing the transformations. What's the negative on the outside of the function tell us? Reflect in the, which axis is that one? Reflect in the, that's the x-axis. And you can forget it's on the first page, you can go look. And then the 1/8 is on the outside, it's not in the exponent, it's on the outside of the whole function, so that's going to be vertical. And it's going to be vertical what? Vertical shrink. By a factor of 1/8. So if I plug in 0, I got 1. If I plug in 1, then I'm doing e to the negative x. If I plug in 1, I'm doing e to the negative x, which I don't expect you to know. I'm just going to tell you that e to the negative x is about 0.36. Or e to the negative 1 is about 0.36. But that one's not as important to me because this one's a decay. I think putting negative 1 is a little bit more helpful in here. Because if I put negative 1 into e to the negative x, so I put negative 1 in for x, negative, what's e to the x? And what's e to the x? Or e to the first? 2.718. So that one's a little bit easier to use for that one. Y equals 0 for the y. And I'll graph it. So 0, 1. 1 is about 0.4, but negative 1 is 2.718. Then we'll do our transformations. They're both vertical, so I can do them both on the y side. And I can do them at the same time because they're both multiplication. So I multiply everything by negative 1/8, so negative 1/8. And then this one I've multiplied for you already, so you don't have to worry about taking your calculator out. And since we are on the y side, the asymptote is y equals 0, so I do have to multiply the asymptote by negative 1/8. So 1 is 0 multiplied by negative 1/8. Still 0. So we'll have the same asymptote. But we know this is going to reflect in the x-axis. It's going to reflect over the x-axis. It's also going to have a vertical shrink, so it's not going to be as steep. So when you graph those, you'll see 0, negative 8, approximately. This is really hard to graph. Probably should have changed my scale, huh? It's just going to be flipped down and then be wider. That's all. When you are ready to go on, turn the page so I know you're ready to go on. And then you see this stuff, and these are all log examples. So now we're going to translate with logarithmic. All the same stuff we've been doing. All the same stuff we've been doing. Here's all the examples if you need them. Example 4. We're going to begin with log x, and then we're going to translate it to log negative half x. So when you do logarithmic, you have to start with the exponential. Then you have to switch it. So this has one extra step. We have to start with the exponential. So the first thing you want to say is, what is the base of this log? I'm trying to write exponential. If you're writing good notes and you want to know what you did, exponential. There we go. What is the base of this log that just says log x? 10. It is the common log. It is the base of 10. So my inverse equation is y equals 10 to the x. You're welcome. And then I find my key points. For 10 to the x, that would be 1, 0, or 0, 1, sorry. And 1, 10. And then y equals 0. That's my exponential information. But we're not graphing exponential. We're graphing log. So how do I make exponential into log? Switch x and y. So I've written them down, just switch them, 0, or 1, 0, 10, 1, and then instead of y equals 0, x equals 0. Now I'm going to look at the transformations. So this has a negative 1/2 next to the x in the parentheses. What transformations are happening? Negative, reflect, which axis? And then the 1/2 is horizontal something. What is it? Stretch. Factor of what? Spelled stretch wrong. Factor of 2. So to our x values, we will multiply by negative 2. Our x values will multiply by negative 2. So can I multiply x equals 0 by negative 2? Well, I can. But what do I get? 0. Okay, so I multiplied it. I still get the same answer. Okay, because this one has huge numbers, I am going to change the scale on my graph. I'm going to count my x's by 2's, and you'll know that because I'm writing a couple of numbers down. There, now you know I'm counting by 2's on my x's. I'm just going to count my y's regular. I'll graph my log first, which was 1, 0, and then 10, 1. And I'll use the asymptote. Oh, I just graphed the asymptote wrong. Did you guys copy my asymptote? I graphed it the wrong way. I just did the exponential one. I caught myself though. Sorry. This one? Change color. Sorry. Okay, when we graph the logarithmic, this was, if you look at the exponential, this was a growth. It was a growth. This was 10 to the x, when you look at the exponential. So when you graph your logarithmic, it's also growth. It's going up. And then I multiplied by negative 2. So I'm going to graph those, negative 2, 0. And then negative 21. And I will use my asymptote so I don't cross through it. And that's what the two graphs will look like. Okay, part B. Same kind of question. We notice it's logarithmic. If it's logarithmic, you have to do the exponential first. So exponential. What is the exponent? No, not the exponent. What's the exponential equation? Y equals, what's the base? 1/2 to the x. So that'll give me the ordered pair 0, 1, 1, 1/2. And is this growth or decay? Decay, and usually if it's decay, I like to do negative 1. So it gives me an easier number to graph. Negative 1, 2. Y equals 0 is the asymptote. Then we'll do the log. So to do log, you just switch x and y. So we'll have 1, 0, 1/2, 1, 2, negative 1, and then x equals 0. What transformations do we have? What's the 2 tell us? Is it in the parentheses with the log, or is it outside? It's outside, so that's vertical. Vertical what? Stretch. Factor of 2. And what's the plus 4? Inside of the parentheses tell us. Translate left 4 units. Question? So I'm going to take my y's and multiply by 2. And my x's, I'm going to subtract 4 from each of these. Including my asymptote, which is currently at 0, I'm going to subtract 4. So I'll get x equals negative 4. So my log, I will have 1, 0, 1/2, 1, 2, negative 1. And that one was decay. So the log is going down because it was decay. Then I'll graph my translated one, or my transformed one, I should say. It shows graphs, but there's no, you don't have to graph them. So there's just writing equations. If you feel like graphing for practice, feel free. Okay. So these are the let the graph be a reflection in the x-axis followed by translation 4 units right of the graph of f of x equals to the x. We have to write the rule for g. So remember what followed by means. Simplify. And we do h of x first. And then after that, then we do g of x. We'll separate it into steps. We're going to start with f of x is equal to 2 to the x. It says reflection in the x-axis. And if you've forgotten, you know, what you do for that, you can go look at this notation on the front page. Reflection in the x-axis says that we are taking f of x and doing -1 outside of the entire function. This is vertical. So then I will replace f of x with what f of x is, 2 to the x. And then I will simplify. So -1 times 2 to the x is -2 to the x. Our second part, g of x, is 4 units to the right. So I'm going to do 4 units to the right. That is horizontal. That goes inside of the parenthesis. If I'm doing right, then I say subtract. Remember, if it's inside of the parenthesis, that means you replace x with a parenthesis and put in x minus 4. So I will have -2 to the x minus 4. Replace x with parenthesis x minus 4. Well, there really isn't anything else happening up there, so you can drop the parentheses if you want. You can leave them if you want. Either is fine. But that's the answer. Yep. So example 6, same kind of question. We're just doing it with logarithmic one instead, but it's the same kind. So we'll first do our h of x, which is translation 2 units up, followed by a vertical stretch by factor 2, so that's going to be our g of x part. So f of x is log base 1/3 of x. H of x is a translation 2 units up of f of x. So we add 2 to the f of x function. So f of x is log base 1/3 of x, and then we add 2. And don't put that in parentheses because it's vertical. G of x, and that's simplified. G of x says, now we're going to do a vertical stretch, so we're going to take 2 and multiply it by h of x. This is where people constantly make mistakes. It was on that test I handed back to you. We're going to do 2 multiplied by the previous function, log base 1/3 x plus 2. You see how my 2 is outside of that function. What do I do with that 2? This one. Distribute it. So I'll have g of x equals 2 log base 1/3 of x plus 4. There's some. So if you feel like that is the part that you struggle with, maybe try this first. Because those will be the very end of the assignment. There's graphing in the homework. I'll put it up in just 1 second. But there's graphing, and I have graph paper for you. There's 6 graphs. I mean, I hope you realize there's graphing as we just did a bunch of it. And it's in the book. So, if you grab a book, there should be enough for us to share if you didn't bring your own.